What's going on everyone, you're back with Jono for another quick math lesson. Today we're going to have a look at what a perpendicular line is and how we can find it incredibly quickly without having to do much maths. So a perpendicular line is something that crosses another line at exactly right angles. I always kind of think about it like how a wall and the floor meet each other. If the floor is coming along horizontally like that, a wall has to be at right angles. Otherwise, we're going to have like a pyramid. So if you want a really quick visualization of what perpendicular looks like, is if I've got a line coming up this way, a perpendicular line is going to come and intersect it exactly down here. So while it looks like an X, the only important thing is that each angle around this intersection is definitely 90 degrees. So these four are all 90 degrees. So a line is perpendicular. We can know for a fact that a line is perpendicular when the gradient is a negative reciprocal of the line that we already have. They are quite big words, but we're going to see that it's really easy to find out what this actually means. If you are looking for a proof of this concept, I've linked two videos in the description below that really go into how we know for a fact this perpendicular rule always occurs. But for this video, we're just going to look at how to use this really quickly in an exam condition. So let's take this as an example. Y is equal to 4x. That line there is just a representation of this. I know it's positive and it's going up kind of quickly. A perpendicular line is going to come through and intersect it like this to make sure that everything there is 90 degrees. The important thing about this is straight away you can see that that blue line has to have a negative gradient. It's going in the exact opposite way. So you need to know straight away perpendicular has the opposite gradient of the original line. The other thing that's really important is that first line there, that black 4x, is going up quite steeply. If my blue line or my perpendicular line had the same gradient or negative 4x, it would be coming down really quickly as well. It would look something like this. That obviously still is an X, but none of those angles that are formed are 90 degrees. So instead of having the exact same gradient, it's got to have a much, much shallower gradient. It's got to go down way more slowly. So the reason that this is important is because I know that the gradient is the negative reciprocal. Reciprocal means switch on a fraction, and negative is obviously the opposite sign. So for this one, the perpendicular line that is I've drawn there has the formula of y is equal to negative 1 over 4x. The y-intercept can be whatever, it doesn't really matter, but as long as that gradient is negative and has the flipped fraction, you know you're definitely right. So another example here is if I've got y is equal to negative 3 over 2x, the gradient of the perpendicular line is going to be the opposite sign. So for this one, it's going to be positive and it's going to flip the fraction. So instead of 3 over 2, I've got 2 over 3 and the line is just 2 over 3x. Again, the y-intercept doesn't matter. The gradient is what's important. Another fact about these perpendicular lines is that the first gradient, or m1, multiplied by the perpendicular gradient, m2, always equals negative 1. This is because they are actually reciprocal, and we're going to see this right now. This is really helpful to answer questions that will come up like this. Is the line y is equal to 3x perpendicular to the line negative 1 over 3? If you can't remember that it's a negative and a flip, you can just type into your calculator, does 3 multiplied by a negative 1 over 3 equal minus 1? For this example, it does, so we know that they are definitely perpendicular. So this is really helpful for when a fraction hasn't been simplified, and this is where a teacher could get a little bit nasty to try and test your knowledge in a test situation. So for this one, I've got negative 10 over 6. Is that perpendicular to the gradient 3 over 5? Because they don't look like the same numbers, immediately you'd go, oh, I don't think so. But if you type into your calculator, does negative 10 over 6 multiplied by 3 over 5 equal negative 1? For this example, it does. So these two lines are definitely perpendicular, and you've got that one right. Again, this is just a really quick introduction to this topic. If you are looking for more detail, please have a look at those videos linked below because they'll really go into the concepts of why these work. I hope you found this helpful, and I'll see you guys later.